Thanks everybody for attending tonight. Really appreciate it. My name is Doug Sartori, and I am a panelist on Mean, Median, and Moose, which is a podcast focused on working with public data in Canada. If you're interested in learning more about it, you can check it out at meanmedianmoose.ca. I'm really appreciative of Hackforge for facilitating and organizing this meetup and giving us an opportunity to chat together. Today's talk is a brief slideshow and demo. Okay, so we're talking today about ETL using Python. Pretty focused on the Python programming language, but the other piece of that is the process of ETL. That's an acronym that stands for extract, transform, and load. And it's a pretty common operation. This is one of the most common things that we have to do in working with data. And it is the extraction of data from one or more data sources, then transforming it by cleaning, aggregating, standardizing, and so forth to make that data conform to what we want to see in our target system, and then loading that data into the target system. This is work that I do all the time professionally. It's something that has been a mainstay of my professional work for a number of years, but I'm pretty new to Python, particularly using Python for ETL. That's something I've only been doing for a few months, but I'm really excited about it. I've learned a lot, and I'm hoping that I can share some useful stuff with you folks. ETL is something where the tools are really varied. It's a big field. There are more tools probably than any one professional could hope to gain meaningful experience with. The tools that people use for ETL range from simple things like text editors or Excel and spreadsheet tools like that for manipulating data for one-time transformations. And almost all of us have probably done that type of ETL work at some point or another. All the way to the other end of the spectrum, the more formal ETL tools that often use a graphical user interface for managing a complex pipeline of loading, transforming, and extracting data. And somewhere in between are the scripting languages like Perl and Python and SQL itself. I think it's important to think about the problem that you're working on when you're deciding which tool to use for ETL. There's a place for all of these tools in the landscape. The professional tools at the higher end of the spectrum, the one I'm most familiar with would be SQL Server Integration Services, SSIS. Those tools are really useful in enterprise environments where you're dealing with large volumes of data and processes that need to execute time and time again on big volumes of data in relatively constrained timeframes. That's where a formal tool like SSIS would shine. The scripting languages, I think, are more useful when you're dealing with maybe a smaller process or a more informal process. I've often written Perl scripts for one-off data transformations or to create one data set to work with in one particular use case and then never looked at it again. And those are great opportunities to use the smaller tools. Although I think that over the years, the scripting languages have become more viable as ETL tools in themselves, and you'll find them crowding that higher end of the market. In particular, I think when you're dealing with, sorry, I'm just letting a few more people in. Welcome, folks. When you're dealing with data that is coming from sources like internet APIs, the scripting languages are really valuable for that type of work, and we'll get into some of the reasons why. So the demonstration tonight, a simple example of an entire ETL process. So we've got data from a couple of different sources that we're going to process in our Python script, and then we are going to load them into our target database. So we have two different data sources. One of them is the Bank of Canada Valet API. If you've never worked with it before, this is something that's worth taking note of. The URL is there. The Valet API has a ton of really interesting data sets in it. If you are looking to expand your skills and looking for some data to work with that that you can use in demo projects or in your own work, this is a great place to start because it contains hundreds of different data sets, lots of different tools, and it's really interesting, very reliable, highly recommended. The URL again is there on the slide, and also the formats that the Valet API supports are XML, JSON, and CSV. So depending on your use case, you may find that a different data format is good for you, but we're going to be consuming JSON data. And specifically in the Valet API, what we're going to be looking at in our specific use case is the exchange rate data. A couple of years ago, I did a similar talk using SSIS to get this same data. And let me just paste the URL for that code repository into the chat so that if you're interested, you can take a look at it. And one of the reasons that I chose to do that was so that we'd have the opportunity to compare different solutions working on the same set of data. There you go. So if you're interested, you can take a look at that code, which is consuming this same data set, and that might be interesting to you. So you see the URL for this particular API endpoint is there on the slide, as well as a sample of the data that it returns. The Valet API is a dictionary. That's the way that the data is formatted. There is 3 keys in this dictionary. The terms key that gives you the terms of use for this particular API. Then there's a nice little key called series detail that gives you the label for this particular data set. So if in your application, you are using multiple different data series from the Valet API, that key will give you some valuable information that you can use in your work, descriptions and labels for the different data sets. And then there are the observations. So the observations key contains an array. And I just want to get into some of the details on this. I'm going to use my mouse pointer to point out some of the details here. So again, the observations key contains an array, but that array is an array of dictionaries. And this is a little bit more complex than this particular data set requires, but I assume that some of the other data sets provided by the API require this level of complexity. So we've got 2 keys in our observations array within each element. One is the D key that identifies the particular date for this observation. Then the next key, in this case, it is this is actually data from the monthly data set, although we'll be consuming the daily data set. Their structure is the same. The label here, FXMUSD CAD, so that's the monthly USD to Canadian exchange rate. And then that key contains another dictionary, which contains, in our case, one key, the V key, which provides the value for that particular observation. So this data could be a lot more simply represented. Again, I've got to assume that this particular structure is used for more complex data sets as well. But what this all means, and the reason that I wanted to point it out, is that when we get into working with it, we're going to have to deal with that level of complexity, with that data structure, and unpack it into a format that we can work with. Okay, on our process flow, we had 2 data sources. The other data source in this case is an Excel document. So what we're simulating here is processing of expense reports. It's a pretty common use case where we have a whole bunch of expense reports sitting in Excel documents, and we need to make sure that they're all in a common currency. So in this case, Canadian currency. I've taken what would be an expense report and broken it down to, or condensed it down to the simplest possible representation. In real world data would probably have many more columns than this, but in our case, all we have is the date of the expense and the amount in US dollars. There's an area where if you would like to work with this data and work with the script that we've got here and try your hand at making this scenario a little more complex, this is one place where you could do it. You could start to add some complexity to the source document and see what you need to do to adapt to that. But for the purposes of this demo, I tried to make it as simple as possible. So we've just got an Excel spreadsheet, 2 columns, date and dollar amount. And for the load part of extract, transform, and load, we need a database. So again, I've created a database. This is the DDL, the data definition language that creates and describes that database. It's a database containing one table. Again, for the purposes of this demo, wanted to keep it as simple as possible, but in the real world, of course, your target database would contain many more tables and a more complex structure. For example, here we have one table containing the date of the expense, the amount in US dollars, the exchange rate, and the amount in Canadian currency. In a real world database, we probably would have a separate table of exchange rates, and we probably would not store the calculated value of the amount in Canadian in the database. We would probably perform that calculation in our application. But for the purposes of the demonstration, I wanted to create something nice and simple. So this is our database. Okay, and along with Python, in order to do the transformation work, we are going to be using a tool called petl. Petl is a Python library that is used for ETL work. It's a lightweight library. The URL for petl is there on the screen, both the documentation and the source code. I've really enjoyed working with it. I've been working with it for a few months, and I find it to be really easy to use and very efficient. However, you've got lots of options if you're doing ETL work with Python. Just to give you a few of those other possible options, there's Pandas, which is a very widely used tool for data analysis with Python. The functionality that petl provides is a subset of the functionality of Pandas. Pandas is not as focused on ETL as petl is. It gives you a lot more bells and whistles in terms of being able to create graphs or do analysis work directly in your application. So that's something to look at if you're interested in that type of work. Then there are a couple of other frameworks available. The thing I wanted to do here was not get into the details of each of these frameworks or modules, but rather to let you know that there is a big ecosystem of ETL tools in Python. And if you're thinking about using Python for ETL work, you probably would benefit from exploring the landscape to find the exact tool that's right for your use case. But for our purposes today, we're going to be using petl. And we're going to be creating a script called etldemo.py. And before we get into the actual coding, I wanted to show you, just focus on the libraries that we're going to be using in this script, because I think it's worth talking about. One of the strengths of Python is the ecosystem of third-party modules that are available for it through its package management system. And even for a simple script like this, there's a whole lot of power available to us in those external modules. So besides petl, which we've already touched on a little bit, we're using the OS module, which gives us tools to interact with the operating system and the file system. PyMSSQL, which is the specific Python driver for Microsoft SQL Server. That's the database engine we'll be using today. petl will work with any standard Python database library. Anything that conforms to the DB API will work with petl, and it will be transparent once you've made your database connection. It doesn't matter to petl what you're working with, but in order to make that connection, we do need the driver, in this case, PyMSSQL. ConfigParser is a module for working with simple configuration files. I included this because this is a pretty common requirement in ETL work. We want to take the variables that are going to be frequently modified to configure the operations of our script and move them out of the code. And the reason that we do that is that not everyone on our data team is necessarily a programmer. Not everyone who's going to be working with this tool is necessarily a programmer. And also, you may want to create a executable package for your Python script, which would make it really difficult for users to be able to modify it. So for that reason, we use a configuration parser to populate some of the important variables in our script. The requests module is the tool that we use for making HTTP requests, which is how we access APIs that are out there on the web. This is probably one of the biggest strengths of doing this type of work in Python, is how convenient and easy it is to work with APIs through the requests module. Then we've got a couple of modules for working specifically with data types that we're going to need. The date time and the decimal module, both of which give us some tools for working with data that we're going to need. And finally, the JSON module, which is going to allow us to consume the data in the JSON format from our API and turn it into native Python objects that we can manipulate. Just before we get into scripting, I want to talk again about those data types, and maybe a good way to do that would be to show you our DDL and actually do the DDL operations. Okay, so we've got a SQL Server Management Studio window open here. And here is our DDL script. We're going to execute it, which creates our database and creates that table. And again, going back to the data types that we were talking about before. So we have some very specific data types that we want to use in SQL Server. It's strongly typed. It requires you to explicitly identify the exact data that you're going to be storing, which is pretty common among relational database engines, of which are a common target for ETL operations. And that's one of the points of friction when you're using a scripting language like Python that is dynamically typed versus a statically typed database system and language like SQL. And that is that the types in the SQL Server are extremely explicit, to the point where we need to define not only the general type of data that we're storing, but also the exact size of data that we're expecting. So you can see there that the exchange rate data, it's not just specifying a decimal, we're specifying the exact size and precision of the decimal that we're going to be storing. This is really important for a number of reasons, and it's really valuable that SQL Server is strongly typed like this. It allows us to eliminate whole classes of error from our system. We know that the data that's going to be stored in those columns is the exact style and representation of data that we expect, which again allows us to eliminate whole classes of error. But again, it creates that friction point when you're dealing with a scripting language that is slightly less precise when it comes to data types. the dynamically typed languages don't do type checking at compile time. They check the data types at runtime, and they are a lot more flexible in terms of what kind of data they accept. So we have to keep that in mind, and that's one of the reasons why we need those additional modules for the, sorry about that. Let me bring back my scripts. We need the additional modules for the specific data types that we're working with. So we've got a nice blank canvas here. Before we get into the actual coding, here is the ini file, which contains our configuration variables. So these are pretty typical things that you would want to move to an external configuration file. The specific date that our script is going to start in terms of the data source, that is the start date we're going to supply to the API. The URL of the API that we're connecting to, the name of the database server that we're connecting to, and the name of the database. So those are all things that could easily change during the life of this system in production. So we move them out into a config file. Okay. All right, so let's start with actually reading the data from that configuration file. To do that, we first need to instantiate our configuration object. So the ConfigParser module has an object called, or a method called ConfigParser, which allows us to create a new instance of that object, which we are going to call config. And now we're going to read our configuration file. I went back and forth on whether or not to include exception handling in this script because it gets a little bit, makes the overall script a little bit harder to read, but I thought it was valuable because it's important when you're doing this kind of work to make sure that you're not inadvertently loading bad data into your system. And one of the ways that we do that is by carefully monitoring all of the IO operations, the input and output that is part of our ETL process. And in Python, the tool that we can use to do that is exception handling. So although what we really want to do here is this one line of code, which is reading our configuration file, that file that we specified, we're putting it inside of a try stanza, a try block, and making sure that that works. So what that structure does is basically makes sure that the code executes the way we're expecting. If any exception is raised, which is an error in Python, if any exception is raised, then the code under the except block will execute. So in this case, we're going to have a pretty simple exception handler. We're basically going to tell the user by printing the text on the screen, hey, we couldn't read this file, dump whatever error messages we get back from Python, and then quit. Okay, so now that we've got our configuration data, we can read it. Okay, so we are populating a set of variables with the values from our configuration file. Just for fun, let's try this out and make sure it's working. Okay, so the script so far is working well. There's the URL. So what that tells me is that the configuration file was read, and we can rest assured that all of those configuration variables are going to be read into the system and populated the way we want. So that's good. Okay, next we are going to get the data from the Bank of Canada API. So again, we're using a try block to make sure that the request to the internet is successful. And we're creating a request here using the get method of the request object, which asks for a URL and parameters, which we are supplying here. So we're taking, remember, the URL is there and the start date is there. So we're combining those into one URL and making that request. And what we get back is the response object, which gives us a whole bunch of ways to operate on the response that comes back from the HTTP server. We can do a whole lot of different things with it. In our case, we're really only interested in two of the properties of the response object. That is the status code. So just a crash course in HTTP. When you make an HTTP request like this, the server will respond with a status code. 200 is the code we want. That's the code that means okay. You may be familiar with some of the common error statuses like 404, which is what happens when the resource isn't found and so forth. So we care about the status code that we get back, and then we care about the body of the response that we get back. So why don't we run this code with another print statement and take a look at the data that is coming to us live from the API. Okay. So there we are. There's the output, and this should look pretty familiar to you if you were watching earlier and you saw what was on the slide. This is the data that we expect to see. It's in the JSON format, and everything looks like it's working well so far. Okay, now I'm going to need to do something that isn't going to make a whole lot of sense until later. There are a couple of empty arrays that we need to populate. And that goes back to the comments that I made earlier about the kind of weird structure or the highly complex structure that the Bank of Canada API uses to store that exchange rate data. What we're going to need to do is basically find those values in the data structure and populate a couple of arrays. So we have those two arrays are for that purpose, the Bank of Canada dates and Bank of Canada rates. Okay. So I mentioned a moment ago the status code that would come back from the our request in the response object. So we have an if statement here, and what we're doing here is making sure that the status code is 200. That means okay, and that means that we've got we were successful in our request and the server gave us back a response. So what we do with that is then we use the JSON object to take that text that's coming to us from the response object and turn it into JSON, which we'll store in the variable BOC raw. One thing that I want to mention is that the request module actually gives you tools to consume JSON directly. So you could do it that way if you like. I chose to do it like this, consume the raw text and turn it into JSON with the JSON module, but there are a few different ways to do it. So for those of you who aren't familiar with Python, Python does not have the typical sort of programming construct where we use semicolons to end a statement and the language doesn't care about how we choose to structure our code visually. It's looking for those markers to separate statements. That's a little bit different in Python. In Python, what matters is the indentation. So you may notice that the rest of the code is going to be indented. It's going to be indented at least one more tab stop. And the reason for that is that everything after this in the script is contingent on that status code being okay. if the status code comes back from our API request that it's not okay, then we can't get the exchange rate data. So we can't connect that exchange rate data to anything else. So we might as well not bother. And I just wanted to point that out because control flow in Python is a little bit more subtle than you might be expecting if you're not familiar with the language. So that's the reason why everything else will be indented. So I mentioned a moment ago that we get the observation data in a really weird format, and we need to do something to make it usable for us. And what that looks like is we're going to take that data and populate those two arrays, which are actually going to be what petl refers to as a column array. So there are a number of different ways that you can load data into petl. And one way that you can do it is by having arrays of columnar data. So each column in a table can be represented by a separate array, and then we mash them together to make our petl table. Okay, so what we've done here is now this is another control flow construct. We are now creating a loop to loop through every row in the observations array. So going back to the slides, remember that the observations key in our API response contains an array of observations. So we're looping through every row in that array with this for loop here that we're declaring. And whatever we do in the next lines that are indented under that for statement are going to be repeated for every row in our data. Okay. So first we're going to work with the dates. So what we're doing here is we are taking our date array and we are appending to it, which means we're adding a new element at the end of that array. And what we want to do is add our date. So what we're doing here, though, because we're later going to be comparing this data, so this is a really important point. We're later going to be comparing the data from the dates column in our Bank of Canada source data. We're going to be comparing that with dates from another data source. And in order to compare them effectively, they all need to be in the same data type. But that's not obvious in Python the way that it is in other programming languages like SQL, where we have to strictly define all of the types of all the data we're working with. So what we're doing here is we are forcing that data to be the particular type that we need it to be. So if you skip this step, or when you're working with petl and you find that you're encountering problems making data connect, this is one of the things that you should think about first. Are all the columns of data that I'm working with, are they all the same type? So what we're doing here is we're using that datetime module that we talked about a little earlier, okay? And we are using a method called strp time, which takes a string and turns it into a date that Python understands as a date. So the data that comes back from the Bank of Canada API, the dates are structured year-month-day. So we are identifying that this is the format that we're expecting that data to come back in, and we want to turn that into a date. So we're looking in row, our row of data, the particular row in the observations array that we are working with. There's that D key that we talked about, the key that identifies the date. This is the structure that date is going to be in, and we want to convert it into a date time and hang it on the end of our Bank of Canada dates array. So all of that is happening in this one line of code. Then the next thing that we need to do is we need to do the same work to get our Bank of Canada rates into a column array. So we have that BOC rates array. We're going to append a row to it. We are going to look in our row of data that is coming back to us from the observations in our data source. In this case, we now need to go 2 levels deep, because if you remember when we looked at the data coming back from the API, the row has the specific type of currency and type of observation that we're looking at, and then that is itself a key, which points at a dictionary that contains only one key in our case, and that is V, which gives us back the value. So, and just like we did in this line of code above, we need to make sure that we are explicitly storing this data in a decimal type. And we don't want this to be a floating point for the reasons that I stated earlier. We don't want this to be an approximation of the number that we want. People get really cranky when you use an approximation of the dollar amount that you owe them or that they owe you. You need to use the precise value. And so for that reason, we're using the decimal module to specifically store that data and preserve the exact value, which might not happen if we use a floating point. So now at this point, we should have two arrays populated that that contain the values that we got from the API. So at this point, we have extracted the information that we wanted to get from the Bank of Canada API, and we have done the initial transformation to turn it into data that we can work with. So let's just take a look at what that output looks like. Okay, so this is Python printing for us a representation of the array. And what we're seeing here is a whole bunch of decimal values. So there you go. Those are the exchange rates. They're not a whole lot of value to us without the accompanying date, but that's going to happen at the next stage. We're going to combine those two arrays into one table. Okay. We've done a lot of stuff so far. Okay, and now finally, after 49 or so lines of code, we're actually going to start using petl. So, and the way we're going to do that is we are going to create a petl table from those two columns, and we are going to give the columns the names that we need. So petl stores data internally in tables, which you can do a lot of things with. And there's a lot of methods that are available to us to work with Python or with petl tables. So we want to get our data as quickly as possible into that petl table representation. So let's do that. And now let's take a look at what our exchange rates look like. Okay, so we're just getting the first few rows. Petl, when you print a petl table, it will just give you a sample of the data, not the whole data set, which is fine for our purposes. So now you can see that what we've done with all of that work that came before, we've got now to a point where our data is in a table representation inside of our script. So now we can consume the next piece of data, which is going to be the expense document. If you remember, the expense document was stored in Excel. It's a 2-column Excel spreadsheet with dates and amounts in US. So just as we did before, we're going to use some exception handling here just to make sure that the document is there and everything that we expect is where we want it to be. So petl gives us some functionality that is inherited from the Python module for working with Excel documents. You can read and write Excel documents with petl. Here we're using petl.io.xlsx to read a specific Excel document and to read the data from a specific sheet. So yes, those were my GitHub expenses for 2020. What's nice about this is, first of all, it's nice because it's so clean and easy to read data from Excel with petl. But the other nice thing about it is that Python also has a module that petl consumes that deals specifically with these documents. So we're not going to get into it here because our target is a database. But if you are targeting an Excel document, you can do a lot of really cool stuff with it. You can put formulas into certain cells. You can explicitly create named ranges. There's a lot of capability there, and you can do all that within your Python script, which is pretty cool. In our case, all we need to do is read that data, and we'll take a look at it just to make sure that it's what we expect. Uh-oh. There we go. Okay, so there is the petl table, because again, we loaded that data into a petl table. There's the petl table that is representing our Excel spreadsheet, and you can see there are the dates and there are the amounts in US dollars. So we've got everything we need, and now we have two tables that we can join together to get the data that we want. Because if you remember, the target database contains some of the values in the Excel document and some of the values in our Bank of Canada data. So we need to combine them now. I want you to pay attention though to this detail. There are a couple of expenses a month here. So this set of dates is really sparsely populated. This is not, by far, it is not all of the days of the year. And an expense report might contain multiple values for one day, or it might contain no values for one day. And it's really important to remember that when we're working with it, because that's going to constrain the kind of operations we can do. So we've got a set now of Bank of Canada observations, daily Bank of Canada observations. So there's an exchange rate for every day, except that the Bank of Canada does not report exchange rates on weekends. So there are no Saturday or Sunday observations in our data set. So the exchange rate data set is also sparse. It's also missing dates. And what makes that even more problematic for us is that we can and do register expenses on weekends. So we've got a little bit of a data problem that we have to fix here, because we have some dates that are only exist in one table or the other table. Okay, so to deal with that, we're going to need to think about that when we decide how we join our tables. For those of you who are experienced with doing database operations, you're probably familiar with doing things like left joins and right joins and inner joins. So, and in most cases, those are the right types of things to do. What we would want to do is we would want to, in the normal case, if we had all the data that we wanted, we would want to take the expenses table and join the exchange rates to it to only get exchange rates for the dates that existed in our expenses table. That we would do as an inner join. That we're only dealing with the intersection of those two data sets. But in this case, that's not going to work for us because of the problem that I identified. So what we actually have to do is this is the most interesting piece here, folks. So if you're thinking about riding the roller coaster, we're ticking up to the top of the roller coaster hill. This is about the most exciting it's going to get tonight. So we have to join these tables. So we are going to do an outer join. And so this is a full outer join. What that means is that we are going to get a result that has every value from our Bank of Canada data and every value from our expenses data. So let's take a look at what that looks like. You may note that I'm reusing table names here. So we are we're not creating a whole bunch of separate petl tables. Once we know that we're not going to need the old data anymore, I'm just reusing that table name. So we're replacing the expenses table with an outer join. And so just to give you a little more detail on what's happening in this line of code, we are identifying the two petl tables that we want to join, the exchange rates table and the expenses table that we created, and the key that we want to join them on. Okay, there are a few different options. If you dig into the petl documentation, you can see that there are a few different ways that you can join tables. We're not going to get into those details right now. We're going to join tables on one key, and that's the date. Okay, so let's see what we've got so far. Okay, so again, we're seeing just the a subset of what is in the table that we're printing. We just get to see a small amount, and what we're seeing here are the first few days of exchange rate data. You'll note that January 1st is not in the data, either because it's a holiday or a weekend. So that's not an observation that happens. But January 2, 3, 6, 7, and 8 are all there, and they all have exchange rates. So we can't see any of the values in this sample, but at any point where there is both a rate and a US dollar amount, we're going to get both of those values because we're joining these two tables together. So we'll see the value that was in the expenses table and the value that was in the exchange rates table. We'll be seeing both of those in the joined column. In the case where we don't have a currency observation and we do have an expense report, we'll see none in the rate column and a value in the USD column. Okay. So how do we fix the problem of not having an exchange rate for every day? petl gives us a tool to fix this. And it is really handy. And it's called fill down. So what we're doing here is just like in an Excel document where you might grab a value and fill it down into blank cells. That's exactly what this utility function in petl does. We're looking in the expenses table and we're looking for blank rates. And so we know, because we know our data, that that means it's a holiday or a Saturday or a Sunday, and there was no exchange rate. So it's perfectly reasonable for us to use the last good exchange rate on those days. And the last good exchange rate will be the one from the day before, from the Friday or the day before the holiday, which should be the value that is just above the blank value in our table. So the fill down function is perfect for our purposes. So what this is going to do is give us now a situation where every row that has an expense is also going to have an exchange rate reported. So we're almost home, because now we have a big table full of a lot of values that we don't want, which are days when we had no expense report, mixed together with a bunch of values that we do want, which are the days where we have an expense report, and now we also have an exchange rate on that day. So the next thing that we need to do is we need to get rid of the data that we don't want. And so we're going to do that by, again, replacing the expenses petl table. And we're going to replace it now with the result of a select statement, okay, or a select, a petl select. So those of you who are familiar with databases will be familiar with the select statement. The purpose is pretty similar. Basically, what we do is we identify a table, and then we identify our condition. In the case of petl, the way that we supply our condition is we supply it as a lambda function. A lambda function is the fancy modern word for what we used to call anonymous functions a long time ago, and it is a piece of code basically that you pass around and can move around in your script and apply in many ways. So in this case, we are creating a lambda function that is going to be passed a record. Okay, that is the record that is being passed in from the petl table. So the select statement will evaluate every record and pass that record to the function. So then what we want to do is we want to check the USD column in that record and make sure that it has a value, because those are the only records we care about. The records that have no value for USD means there was nothing in our expenses table, and we can get rid of them. So we are selecting only the subset of rows that have a value in the USD table. And now I think is a good time for us to take a look at what we've got so far. Well, you look at that. We have only the dates that we care about, which are the dates from our expense report, and we don't have any gaps. We have an exchange rate reported for every single day, and we have a US dollar amount. So we're almost there, folks. And I know this has been a lot, but we've only got a few more steps to do before we're done. Next thing we need to do is we need to add our Canadian data column. So we want to populate our target database. Remember, has 4 columns. It has a column for the date. Okay, we've got that. It has a column for the exchange rate. Okay, we've got that now. It has a column for the amount in US, and it has a column for the amount in Canadian. We don't have that yet, so we need to add it. So we're going to use another petl function, which allows us to add a field to a column. In this case, because we're not getting this data from anywhere, we're synthesizing this from information we already have. We're just adding a calculated field. So this is the tool that we would use in petl to add a calculated field to our table. So we're using the add field function. We are identifying the table that is the target, which is the expenses table. We are naming the new column, and then we're supplying a lambda function that gives us the value that we want. So in this case, we are taking the rate and we are multiplying it by the amount in US dollars. So remember that we got that US dollar amount from an Excel spreadsheet. And what we don't want is we don't want that to turn into a floating point number. And we don't want that to be represented as a string. So we are explicitly telling Python that we want to work with this as a decimal. The rate value is already a decimal. So now we're ending up with values that we can work with. So in SQL Server, those are going to be the CAD and the USD columns are going to be money data type, but we're using the decimal type all the way around in petl. Okay, so we should now have a table that we are ready to load into our target database. Let's take a look. And there we are. And now the amount in Canadian dollars is there for us. So we have a table that looks pretty much like what we need to go into our database. And I hope you'll agree. Whoops. I hope you'll agree that that was actually pretty painless and simple compared to working with some other heavier weight ETL tools to do all these operations. So the last thing that we need to do is make a connection to our database and populate the expenses table with the data. Once again, in a try block, we are encapsulating our request to the Python Microsoft SQL module to connect to a server. And you may remember that, excuse me, you may remember these values from the configuration file got populated into variables, and we're finally using them. The destination SQL server and the destination database name. So assuming all goes well and we don't end up with an exception because we can't connect to that database, we are ready to go and populate our data into our database table. And we do that with petl. Again, making sure with a try block that nothing weird happens. And we are using now petl's IO function to load data in a database. And it's pretty straightforward. We use petl.io.2db. We identify the table. We identify the database connection that we are using and the target table, which is the table name that we set up called expenses. So let's run this script one last time. And what we should get is no errors, press any key to continue. So we're going to switch over to our database and take a look at the contents of our expenses table. And there we are. So we have successfully taken data from multiple sources, transformed it according to the requirements of our particular application, and loaded it into a target database. That is ETL with Python.